Hi viewers, welcome to Labs. Today we are going to see about 2 megawatt PV battery grid system in MATLAB. This is a simulation model for 2 megawatt PV battery based grid integration. This model consists of main grid. The main grid is rated at 154 megawatt, 34.5 kilovolt, and then here we have a transformer. That means step down the voltage from 34.5 kilovolt to 400 volt, and then in point of common coupling we have load is around 1.6 megawatt, and then here we have PV battery system. Here you can see that the battery is going to be connected to the DC link. Here you can see that this is structure of the connection, actual connection. Here we have PV is directly connected to the DC link, and here we have battery connected to the DC link via bidirectional converter, and then after that DC link we have inverter for connection to the point of common coupling. Here AC grid. So these are the DC points. Here you can see that we are using around 300 volt nominal voltage battery with rating of 2 megawatt. That means here we will see that 2 megawatt with 300. This rating around 6.6. That means the rating of this battery is around 6.6 kiloamps hour. Why we are using this kind of battery? Because we are connected to the 2 megawatt PV power generation. That's why we use this, and then it going to be connected to the DC link via this bidirectional converter. So this bidirectional converter controlled by means of current control method. Here you can see that we are generating the reference current based upon the PV current. That means we are taking only 20% of PV and then yes added with the 800. This will be generate the reference current. So reference current that means based upon the PV current or PV power. So it will be generate the charging current for a battery and a discharging current for battery according with the PV current. And then after it going to be compared with the battery current, actual battery current going to be processed via PA controller, and then it going to be processed via generator. So this PWM generator going to be generate the pulse for controlling this 2 IGBT of this bidirectional converter in order to control the current of the battery according with the reference current generation based upon the PV current. The next one thing, PV array system. Here you will see that this is a block inside that the solar PV battery system. Here you can see that there is a solar panel. The single panel rating is 414 watts, and then voltage is 72.9, and current at maximum power point is 5.16 amps. And then each string having 7 series PV panel connected in series, and then here we have 700 pulse string for generating the 2 megawatt power. So this is a common DC link. In DC link we are connecting PV as well as battery via this bidirectional converter. Next we have that inverter control. Inverter control used to control this neutral point clamp converter, and then here we have harmonic filter to filter out the harmonic in the voltage of the output of the inverter, and then in here we have a step up transformer. So this grid inverter can be controlled by means of MPPT method. Here we are using P&O MPPT. So P&O MPPT going to be generate the reference voltage based upon the PV voltage and current, and here you will get the reference voltage. So this reference voltage going to be compared with the DC link voltage, and then after comparison it going to be converted into per unit by dividing with the nominal DC voltage, and then it going to be processed via PA controller. This PA controller will be generate the ID reference. This ID reference going to be taken as a reference current for a real power injection in the point of common coupling. Here we are making IQ reference equal to 0 because we are not injecting the reactive power, just we are injecting only real power. The next thing is you have to measure the inverter voltage and current in this point. In this point only we are going to connect it to the point of common coupling. In this point you have to connect that you have to measure the voltage and current. After measuring that voltage and currents, you have to convert that voltage and current into, we are having ABC form, so you need to convert it into DC naught form. So by using power transformation, here we are using ABC to DC naught power transformation. So after converting the DC to DC naught, we are getting VD and VQ and ID, IQ. For converting ABC to DC naught, here we are using PLL. PLL will be generated omega T for this inverse power transformation block. Finally, here you can see that we are having VD, VQ actual, ID, IQ actual. Here we have ID, IQ reference. Then here inside, here we are going to apply it for our decoupling control. Here we are comparing that ID IQ reference with ID IQ actual, and then when we process we have PA controller, and then here we are applying that feed forward decoupling control logic, and also it will be generated some control voltage. So the output from the BA control and then feed forward decoupling control logic so is added here. Finally you will get a final control signal in the form of VD and VQ. The next process is you have to convert that VD VQ into actual form. Here we are going to apply inverse power transformation. For applying, after applying inverse power transformation, that VD will be converted into ABC form. The ABC form going to be processed via modulator. Modulator will be generated the control voltage reference. This control voltage reference going to be control this neutral point converter for sending real power to the point of permanent coupling. And then here you can measure the PV. Here you can measure the irradiation, and then here you can measure PV per PV voltage, PV current, and then here you can measure the source of the battery, battery current, battery voltage, battery power, and then here you can measure load THT, load current, load voltage, load power, and here you can measure grid current THT, grid current, grid voltage. Now I'm going to operate the system. Now I'm fixing that irradiation is around 1000 watts per meter square and temperature is 25 degrees Celsius, and then I'm going to run the model with this operating condition, and then you have to check the results. After something you have to change the irradiation, and then you have to check the system performance. So now I'm going to simulate this model. Here you will see that PV generating that means irradiation is around 1000 watts per meter square. PV generating around 2 megawatt. Here you will see that 2000 kilowatt, that means which is equal to 2 megawatt. Then voltage of the PV is around 500 volt, and then current of the PV is around 4000 amps. Here you will see that SOC is keep on increasing, and then here you can see that battery current is minus 200 amps, and then battery voltage 305 or 310 volt, and then you will get around minus 60 kilowatt. That means battery in charging mode. So that's why the current and power will be in a negative. Here you will see the THT of the grid current is around 0, and then grid current and the grid voltage. Here you can see that grid current, grid voltage nature is sinusoidal, and here you can see the grid power is around we are getting around grid power is around 400 kilowatts. And here you can see that this is a THT of the load current. This is a load current, load voltage, this is load power. Load power is around 1.5 megawatt. Now I'm going to change the irradiation to 500, and then you have to check the result of the system. Now you can see that now irradiation changed to 500 because of that power generation from the PV is around the 1 megawatt only. 1 megawatt. Here you can see that change of irradiation equal to 500 watts per meter square, and then current of the PV is around 2000 amps. Because of change in irradiation condition, battery now comes to discharging mode. The battery power is around 100 kilowatt, and then here you can see that the battery current is around 280 amps. So battery now supplying around 100 kilowatt to the point of, that means DC-link system, right? And then here you can see this is grid current. Now grid power is around minus 450 watts. That means now grid supplying some power to the point of common coupling to manage the load power. So now you can see that the load power is maintained around 1.5 megawatt only, and then THT of the load current is around 5% only. So now I'm going to make the condition to 50, that means low irradiation of the PV, and then you have to check the results. So now you can see that the PV power PV radiation comes to 50, and then PV power comes to around not 0, is around is like around, one second please, PV power is around 100 kilowatt, right? PV generating around 100 kilowatt. Now we can see that the battery light, because of that battery goes to battery now supplying around 200 kilowatt, and then here you will see that grid supplying around 1200, right? 1200 watts, right? Here you will see that load continuously getting power from the system. This is operation of the model with the change in irradiation condition. System will be have the power balance in the source side as well as load side. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much.